Script, energy-based out-of-distribution detection using contrastive score matching in deep generative models. Imagine you're running a cozy neighborhood bakery that's famous for 3 kinds of bread: sourdough, rye, and multigrain. Every morning, loyal customers walk in expecting exactly these, and nothing else. One day, someone tries to sneak in a loaf of banana bread onto your display. As experienced as you are, you instantly spot that it just doesn't belong. But how does your mind do that so quickly? Can a computer, when dealing with complex data like images or texts, possess the same sense, the ability to know when something doesn't belong, even when it's never seen it before? This brings us to today's topic: energy-based out-of-distribution detection using contrastive score matching in deep generative models. If that sounds like a mouthful, don't worry, let's break it down into bite-sized pieces. To start, what is out-of-distribution detection? In the world of machine learning, we often train models to recognize patterns, just like your bakery is used to handling certain breads. But in the real world, sometimes new, unexpected things show up: photos taken under strange conditions, medical images from a rare device, or yes, even banana bread at a sourdough shop. Out-of-distribution, or OOD, detection is about automatically spotting data that doesn't fit the patterns the model was trained on. Why is this important? Without OOD detection, an AI might make embarrassing or even dangerous mistakes: a medical AI misdiagnosing an unknown disease, or a self-driving car misinterpreting an unknown object. But how can we get computers to spot OOD samples? Traditionally, models are like students who memorize their textbooks. They get really good at the familiar, but freeze up when faced with something new. That's where energy-based models and contrastive score matching come into play. Let's begin with the idea of energy-based models. Picture every piece of data, a photo, a sentence, a loaf of bread, as sitting on a landscape. For the data the model knows well, the in-distribution samples, the landscape is like a deep valley. These are comfortable, expected inputs, so they get assigned a low energy. Things the model doesn't recognize well, out-of-distribution samples, are up on the hills and mountains. These are assigned higher energy because the model is less certain about them. If you come across a bread that looks strange, your energy function raises a red flag. But what about learning this complex landscape? How do you know what should be in the deep valleys and what should be far away? That's where contrastive score matching shines. Imagine a teacher asking you not just to remember your regular breads, but also to deliberately compare them to some odd-looking, possible imposters brought in from the outside. This process helps you draw sharper boundaries. You become more confident about what is regular and what is strange. In mathematical terms, contrastive score matching tweaks the model so it becomes excellent at telling what's typical versus what's alien, effectively sharpening the energy landscape so OOD samples are easier to spot. In practice, deep generative models, a class of powerful machine learning models, can be trained with this contrastive approach. Deep generative models already excel at imagining new, realistic data by learning the underlying patterns. When enhanced with energy assignments and contrastive learning, they get even better at not just creating convincing examples, but also telling you, hey, this one doesn't fit. Let's walk through a couple of real-world scenarios. First, imagine a hospital uses an AI model trained on thousands of images from one type of MRI machine. One day, a new MRI machine is installed and produces scans that look subtly different. With an energy-based OOD detection system, the hospital's AI can flag these new images as out of distribution and request a careful review, reducing misdiagnosis risk. Another scenario is in banking security. Banks use AI to spot fraudulent transactions, but every now and then, a completely new type of transaction might appear, maybe a new, very unusual payment method or unexpected spending pattern. A model equipped with energy-based OOD detection can raise the alarm whenever something stray shows up, helping protect against evolving fraud. A third example is in self-driving cars. These cars are trained on millions of road images, but what if, on a dark night, a kangaroo hops onto a highway, a scenario never seen during training? An OOD detector based on energy functions would sense, this is not in my training experience, and trigger a cautious response. So, why should you care about energy-based OOD detection? In AI's journey from labs to everyday life, we want it to be trustworthy and aware of its limits. Identifying when it's seeing something completely new makes AI safer, more reliable, and ultimately more usable across high-stakes fields like medicine, finance, and transport. As AI becomes a bigger part of our decision-making processes, these systems prevent costly or even life-threatening mistakes. Now, you may be wondering, does this mean AI will become perfectly self-aware and infallible? Not quite. While energy-based OOD detection marks a huge step forward, it isn't magic. The ability to spot OOD samples depends on how well the model's valleys and mountains, energy landscape, have been trained and the diversity of those imposter samples shown during contrastive training. If something is truly from another world, say, a recording from an alien MRI, the model might still struggle. But overall, it's much more robust than pretending all bread is just bread. Another common question: does this technology replace human experts? No, think of it as a powerful assistant, always scanning for surprising cases where a human's judgment is needed. In high-risk scenarios, it's a safety net, not a replacement. And finally, is this what powers systems like ChatGPT? ChatGPT is tuned to respond safely to most queries, but it uses different forms of data detection, though energy-based OOD detection is an exciting research direction for the future of language models and other generative AIs. In closing, as AI systems become more deeply woven into our daily lives, it's vital they develop a sense of surprise, the ability to flag what's truly new, unexpected, or potentially risky. Energy-based OOD detection, sharpened by contrastive score matching, is an elegant way to give our models that instinctive alertness. It's like giving our digital bakery staff a keen eye for the unusual loaf, so our shops and our world stay safe and smart as we welcome whatever comes through the